Hey there, space explorers. Ready for another deep dive?
I'm ready.
Awesome. So today we're tackling those mysterious Magellanic Clouds. Ever looked up at the night sky and seen like these faint fuzzy patches?
Oh, yeah, I know what you mean.
I always wondered, what are those
Well,
things?
those patches are the Magellanic
The
Clouds.
clouds.
Not just clouds, no. They're entire galaxies.
Whoa, really? Galaxies?
Yep, orbiting our own Milky Way. Think of them as, like, our cosmic neighbors.
Galaxies right next door. That's incredible. So tell me more. What are these galactic neighbors like?
Okay, so we've got two. The Large Magellanic Cloud,
Okay.
or LMC for short,
Um,
and then there's the Small Magellanic Cloud.
The SMC.
You got it. Now, the LMC, that's the big one. It stretches a massive 14,000 light years across,
Wow.
and it has about 10 billion stars. Inside, there's a star cluster called R136.
Okay.
And that cluster is home to some of the most massive and luminous stars we've ever discovered.
Seriously.
Oh yeah, we're talking hundreds of times more massive than our own sun.
That's mind-blowing. And what about the SMC? Is it kind of just like a smaller, quieter version?
Not really, no. The SMC is definitely smaller.
Yeah.
It's about 7,000 light years across and has like 3 billion stars. But it's got a lot going on. It's a very dynamic place. There's a ton of star formation happening right now.
Really?
Yeah, lots of young hot stars, which tells us there's been a recent surge in stellar births.
Wow. So we've got these two, you call them dwarf galaxies, swirling around the Milky Way, each with their own, character. But dwarf galaxies, does that mean they're like baby galaxies?
Not exactly. I mean, dwarf just means they're smaller than galaxies like our Milky Way, but they're still, full-fledged galaxies
right.
with their own structures and history.
Makes sense.
The Magellanic Clouds are what we call irregular dwarf galaxies.
Irregular, meaning they're not like the spiral shape, like a classic galaxy.
Exactly. They don't have that nice spiral shape or even an elliptical shape.
Okay. So why are they irregular? What makes them so different?
Well, you've got to remember, the Milky Way is there.
Right.
And it's got a lot of gravity. So these galaxies aren't just orbiting peacefully, they're interacting with the Milky Way.
So they're being pulled and stretched.
Exactly. It's like a cosmic tug of war. Gravity's pulling and stretching them as they swing by.
So the Milky Way is kind of being a bully to its little neighbors.
You could say that, but actually, this interaction creates some really cool things. Like, it's thought that the Magellanic Stream is a result of this cosmic dance.
Hold on, back up. The what
The
stream?
Magellanic Stream, it's a massive, and I mean massive, river of gas stretching over, get this, 600,000 light years.
Wait, a river of gas that long? I can't even picture that. How does that even happen?
It's all because of these gravitational forces we're talking about. As the Magellanic Clouds orbit the Milky Way, gravity, both their own and the Milky Way's, pulls away some of their gas and stars.
Okay.
And that's what forms this enormous stream that trails behind them.
So we have these irregular galaxies, a river of gas flowing between them, and this giant gravitational dance happening.
Right in our cosmic neighborhood.
This is amazing. So much to take in.
Oh, we're just getting started. There's so much more to uncover about this cosmic mystery, especially when you start to think about the future.
Oh, what does the future hold for these Magellanic Clouds? Are they going to be stuck in this dance forever?
Not quite. Turns out, those orbits aren't so peaceful after all. The Magellanic Clouds are on a collision course with the Milky Way.
Hold up, a collision? Like, are they going to crash?
Yeah, but don't worry, it's not happening for billions of years.
Okay, good. But, well, what's going to happen when they collide?
It'll be a spectacular event. It's going to reshape the Milky Way as we know it.
Seriously. Like a complete makeover for our galaxy.
Absolutely. It'll be like a cosmic fireworks display.
What?
All that gas and dust merging.
What?
It'll trigger bursts of star formation, new stars all over the galaxy. And Milky Way's spiral structure, it'll probably be completely changed. Maybe even a totally different shape.
So the Milky Way we see now might be unrecognizable in a few billion years.
Yeah, pretty much.
That's incredible.
It really makes you think, about how the universe is constantly changing. Even galaxies like ours aren't permanent.
This is already so fascinating.
There's more.
We've explored these dwarf galaxies, we've talked about their crazy shapes, and now this dramatic future. But what about their past? Where did they even come from?
Ah, excellent question. That's where we'll head next.
I can't wait. And for all of you listening out there, stick with us as we uncover the secrets of the Magellanic Clouds.
Welcome back to our deep dive into the Magellanic Clouds. So before we get into the whole origin story, there's something else I wanted to talk about. Remember the Magellanic Stream?
Oh, yeah. that crazy river of gas. I'm still wrapping my head around just how big it is. It's wild to think about all that gas just out there, flowing through space.
It really is amazing. And it's not just sitting there, it's constantly changing. All these gravitational forces from the Milky Way and the Magellanic Clouds, they're shaping the stream.
Right. Makes sense. It's like a cosmic tug of war.
Exactly. And here's the thing, all that gas, it's not just floating around aimlessly, it's actually feeding our galaxy.
Feeding our galaxy.
Yeah, so the Milky Way is always pulling in material, gas, even stars sometimes.
Like its surroundings.
Yep, kind of like a cosmic vacuum cleaner.
I like that, a cosmic vacuum cleaner.
And the Magellanic Stream, well, that's a perfect example. Some of that gas, as it flows towards the Milky Way, gets pulled in and becomes part of our galaxy's disk.
Okay.
And then you know what happens. That gas fuels the formation of new stars.
So new stars in the Milky Way are being born from gas from another galaxy.
It's crazy, right? It really shows you that galaxies aren't static things. They're constantly changing, growing, evolving.
So we kind of owe the Milky Way's growth to these little galaxies.
Absolutely. It's like a cosmic give and take. The Milky Way might be messing with the Magellanic Clouds with its gravity, but at the same time, it's giving them a supply of fresh gas, which could trigger even more star formation.
It's like everything's connected in the universe. Hey, it's interesting. I was reading that the Magellanic Clouds have been important in human history, too.
Yeah.
Especially for people in the southern hemisphere.
Oh, totally. I mean, think about it. They've been a constant presence in the night sky for cultures in the southern hemisphere for centuries.
Yeah.
Indigenous peoples like the Aboriginal Australians and the Maori of New Zealand, they've incorporated the Magellanic Clouds into their cultures.
Really? In what way?
Well, like the Aboriginal Australians saw them as a representation of a camp of ancestral beings.
Oh.
And the Maori, they actually used them for navigation. They called them the Clouds of Magellan after, well, Magellan, the European explorer.
It's amazing how long before telescopes and all that, people were looking up and finding meaning in those clouds.
It really shows you the connection between humanity and the cosmos, a connection that's been there for thousands of years.
It makes you realize those faint patches of light has so much meaning. They're not just scientific objects, they're part of human stories.
Well said. And it's that sense of wonder, that keeps us exploring the universe and trying to figure out its mysteries. Speaking of mysteries, let's get back to one of the biggest ones surrounding the Magellanic Clouds. Their origin.
All right, where did they come from? Have they always been hanging out with the Milky Way, or did they wander in from somewhere else?
It's the big question, isn't it? Astronomers are still debating it. Are they lifelong companions, or did they get captured by the Milky Way's gravity? It's like a cosmic mystery.
Okay, so we've got two main suspects, lifelong buddies or galactic hitchhikers. What's the evidence?
Well, one clue is their chemical makeup. The Magellanic Clouds have fewer heavy elements than the Milky Way.
Right, we talked about that.
That suggests they might have formed somewhere else, maybe in a region where there weren't as many heavy elements.
So that points to them being from somewhere else, right? What about evidence for them being with the Milky Way all along?
Well, some studies of their movements, how they're interacting with the Milky Way, suggests they might have been orbiting us for a very long time, maybe billions of years.
Okay.
If they were captured recently, their orbits would probably be much more chaotic.
So we have evidence for both.
It's kind of a puzzle.
It's a real cosmic detective story.
Hmm.
But, it makes you think about their journey, whether they've been with us all along or if they just showed up.
It's amazing to think about.
Are there any other big mysteries about the Magellanic Clouds that we haven't talked about yet?
Oh, there are plenty. We've really only just scratched the surface.
Well, I'm ready to keep digging.
Join us for the final part of our deep dive. We'll get into some of the latest research and maybe uncover some more of the secrets of these enigmatic galactic companions.
All right, we're back. Ready to wrap up our Magellanic Clouds deep dive.
Let's do it.
So last time, we were talking about all these mysteries surrounding the clouds. Like, where did they even come from? But you mentioned there's more, right?
Oh, yeah, tons more. Like, remember we were talking about their chemical makeup?
Yeah, how they have fewer heavy elements than the Milky Way.
Right, exactly. So that's not just a clue about their past. It also makes them super useful for studying the early universe.
Hold on. How can we learn about the early universe by looking at these galaxies?
Think of them as time capsules.
Time capsules.
Yeah, because they have fewer heavy elements.
Okay.
Their stars and gas are more similar to how things were way back in the early universe, before stars had time to create all those heavier elements.
So it's like We're looking back in time.
Exactly. It's a glimpse into the universe's baby pictures.
Wow. So what can we learn from that?
Well, we can learn about how the first stars and galaxies formed, how the universe's chemistry changed over time, and even, get this, clues about dark matter.
Dark matter. Wait, those mysterious particles that, like, make up most of the universe's mass?
That's the one.
What do the Magellanic Clouds have to do with that?
Well, they're like perfect labs for studying dark matter. We can't see dark matter, right? But
Yeah.
we know it's there because of its gravity, how it pulls on things we can see. And with the Magellanic Clouds, their orbits, how they interact with the Milky Way, it gives us a way to study dark matter's influence.
So it's like they help us see the invisible.
Exactly. It's like using them to map out the dark matter in the universe.
That is so cool. The more we learn, the more amazing they become.
Right. We've uncovered so much. Their irregular shapes, the future collision with the Milky Way, their possible origin stories.
And now these connections to the early universe and dark matter.
They're like key players in the cosmic story.
I know. It's mind-blowing.
And the best part, there's still so much more to discover.
It's like with every answer, we get more questions.
And that's the beauty of science, right? The Magellanic Clouds, they're more than just pretty lights in the sky.
Yeah, there are neighbors, time travelers, cosmic labs, and they're helping us understand the universe in a whole new way.
Couldn't have said it better myself.
This has been an incredible journey. Thank you so much for taking us on this deep dive.
It was my pleasure.
And to all our listeners, if you're as fascinated by the cosmos as we are, keep exploring, keep asking questions, and never stop looking up at the night sky.
That's right.
And hey, don't forget to follow and subscribe to Cosmos in a Pod and check out our YouTube channel for more cosmic adventures. Until next time, keep exploring the universe.